All right, kiddos, today we're going to be talking about graphing rational functions. And this might pop up on the final in one or two questions. So a rational function has a rule given by a fraction whose numerator and denominator are polynomials and whose denominator is not 0. Well, and why? Because, well, what happens if you have 1 divided by 0? It's no solution. So the domain and range are all non-zero real numbers. 1 over x is going to be our parent functions for these functions. And the horizontal asymptote is the x-axis, while the vertical asymptote is the y-axis. Now, what do I mean by asymptote? That's like the number where our graph won't touch. So if we take a look at example 1, it says the graph of negative 1 over 2x. Remember, our parent function is 1 over x. So if we have negative 1 over 2x, the 1/2 will be a shrink here with a reflection in the x-axis. What could I ask you here? I could ask you whether it's a stretch or a shrink. I will not ask you about the reflection for the sake of the final, but you will dig into that deeper in Algebra 2. All right, take a moment to pause and identify the domain and range of y equals 1 over 4 times x, and compare the graph with y equals 1 over x. All right, so it looks here like our domain or our x values can be all real numbers except 0. Because if you look on the x here, it actually never touches the value of 0 at x. It just gets really, really close. The range is all real numbers except 0. And again, if you look at the y value here, it gets really, really close, but doesn't quite touch it. Because it's a 1/4, it would be a vertical shrink. And again, that's the kind of question that I would ask you on a final. How does y equals 1 over 4x compare to 1 over x? And you say, well, it's 1 in comparison to 1/4, so we have a vertical shrink here. So let's graph y equals 1 over x plus k. And you can definitely use your calculator for this. So when I plugged in each of these numbers, like 1 over negative 2 minus 2, I did negative 0.5 minus 2, so it's going to give me negative 2.5. So pause this for a moment, use your calculator if you need to, and fill out this table. All right, so you have negative 2.5, negative 3, negative 4, undefined, can't divide by 0. 1 divided by 0 can't happen. 0, negative 1, and negative 1.5. So it looks our domain here can be any number except 0. It's kind of hard to see what our range is going to be. That's going to be a little bit easier to see once we graph. They also did want us to compare, and as the rules applied previously, if you're subtracting 2 on the outside, then you're going to have a vertical translation down by 2. Which is kind of nice, like all of these rules are the same. So let's graph this. Let's see how our range looks here. So at negative 2, I'm at negative 2.5. At negative 1, I'm at negative 3. At negative 0. I'm right here. At negative 4, 0, it doesn't touch. 0.5, I'm at 0. 1, I'm at negative 1. 2, I'm at negative 1.5. And if you kind of curve it like that, make sure not to hit that number that it approaches. We actually see here that the number that it's never going to quite touch there is 2. And this is because of that vertical translation down. So here our range is any number except that -2. Because it doesn't quite touch at -2. It gets close, but it never touches. All right? Take a moment, pause the video, and fill out the checkpoint. You are going to need to make a table. Okay? So here, for the sake of our table today, we do see it's going to be 1 over x plus 2. So let's use the same numbers that we had here. Let's see if that's enough information for us. If I had 1 over -2 plus 2, or -0.5 plus 2, I'm at -1.5. Let's actually just go by 1, see if that's enough, and then if we need to, we'll add to that. 1 over -1 plus 2, -1 plus 2 is 1. Oop, I made a mistake here. Good call. And I see that when I filled out my graph. So 1 divided by 0 can't happen, so that's going to be undefined. 1 divided by 1 plus 2, 1 plus 2 is going to be 3. 1/2 plus 2, 0.5 plus 2 is going to be 2.5. So at -2, I'm at 1.5. At -1, I'm at 1. At 0, I don't know. It's undefined, so I don't quite see what's happening. At 1, I'm at 3. And at 2, I'm at 2.5. And as you see here, I can't quite see what's happening, but for the sake of our lesson, it might be helpful to actually fill in 0.5. You'll see that curve there and here. But on the homework, I'll only need 5 points. So if you can already see here that at 2, it's going to curve and it's going to curve there, then you can stop. But in Algebra 2, the teacher is going to make you go into those halves. So it seems here like our domain can be all real numbers except 0, because of course it can't divide by 0, while range are all real numbers except that +2, because we do see here while it gets close to +2, it never quite touches. And if we're comparing, that add 2, shifting everything 2 units up. All right, beautiful. Let's try the next one. See, the next one here is like a 1 over x minus h, so it's slightly different. Take a moment, pause the video, fill out the table. All right, thank you for pausing and filling that out. You got -0.5, -1, -2, undefined. And it's just easier to see in the example, but again, I'm only going to expect 5 points on the homework, 2, 1, and 0.5. I just want you to have an introduction to this. If you don't feel 100% on it, don't worry about it. As long as you understand what's happening to the graph, if you can tell me that the graph is being shifted up, down, those same rules apply as all our other equations. So at -5, I'm at -0.5, -4, I'm at -1, -3.5, I'm at -2, -3, I don't know what's happening, so I might just be able to do our asymptote right there. -2.5, I'm at 2, -2, I'm at 1, and -1, I'm at -0.5. So again, I can go ahead and do that. Here you see it's a little bit different. It appears like the x has now shifted. You are going to explore these types of problems more in Algebra 2. I would not put this on the final. Again, I'm just giving you an introduction to it because you are going to see it in Algebra 2. The other questions above might all be up for grabs on the final. So if we're looking at our domain here, it's all values except -3, because when you plug in -3 on the bottom, you get 1 over 0, which gives us that undefined here. As far as our range, it appears that it never quite touches 0. And we actually have a horizontal translation. So this is the first time in our class that we're really introduced to horizontal translations. And this is shifted 3 units to the left. So 1 over x plus 3, if it's being added, it's shifting to the left. All right, I'm actually going to have you pause this video and try the next one on your own. Thank you for attempting the next one on your own. So let's see if -2, -1, 0, 1, and 2 are enough information. They might not be, just because you see here, what number would you have to plug in for this to no longer work? Very good, you'd have to plug in 1, because if you plug in 1 for x, you have 1 over 0. So it looks like your asymptote's going to be here. You might need those, a couple more numbers, like see here how you have 3 before. You might need 3 after for like a very clean graph. So if you're using your 5 points on your homework, be strategic on what 5 points you're actually going to use. So we're going to have undefined here. The 0 would be 1 over 0 minus 1. So 1 over -1, we're going to have -1 here. Here we're going to have 1 over 2 minus 1. 1 over 1 gives us 1. At 3, we're going to be at 0.5. 1 over 3 minus 1 gives us that 1/2. And then at 4, we're going to be at 1/3. 1 over -1 minus 1 gives us a -1/2 here. 1 over -2 minus 1 gives us a -1/3 here. So at -2, I'm at 1/3. -1, I'm at 1/2. 0, I'm at -1. And again, if this is a little confusing, don't stress about it. It's just an introduction. The one on the final, if there is a question like this on the final, would just say, is it a translation up or down, or to vertical, shrink, or stretch? And cough, cough, we've seen shrink so far. So cough, cough, it's probably going to be a shrink if it shows up. 4, we're at 1/3. So here, I'm going to curve this. Uh-oh, or can I? This is the part where I might need those 1/2s added. It is really hard to see exactly what's happening here. We do know that it's going to kind of shift down here at 1, so we do have to shift it back up to 1. And again, that's algebra 2. As long as you kind of understand that that's what's happening by the 1, that it's going to get closer but not quite touch, then you are perfectly set. So what's our domain and range? Well, domain, we could have all reals except 1. For our range, we can have all reals except 0, because it never quite touches 0. It never touches 1. And then we see here, well, what's happening with this -1? Well, if it's a -1 on the bottom, then it's going to move right 1. This will not be on the final, as I've stated. What you would see on the final is an up or down. I'm not going to give you a right and left for these. All right, let's take a look at the next section here. So I've got 2 over x minus 3 plus 4. Asymptotes are where you have to think about what works for our domain and range and what doesn't. The asymptote is what doesn't work. So when you're referring to a vertical asymptote, if you were to draw an up and down line, what's that x equals that it doesn't work for? The horizontal asymptote is that right and left y equals line. What does it not work for? So here, for what x value does this not work? Well, we see here that the only way to get 0 on the bottom, to get that 2 divided by 0 plus 4, is if we plug in 3 to give me 3 minus 3 as that 0. So here for x equals 3, that is my vertical asymptote. For what value of x, if I plug in, do I get 0 on the bottom? Again, the horizontal asymptote is a little harder to see unless you actually create your graph. And what you could think about is you might have discovered a pattern of where that asymptote is. Look back on the previous examples and see if there is a way that you can see where the vertical asymptote is. Okay, so hopefully some of you guys were able to see the pattern that if you have that 0 on the bottom here, it's usually the number that's on the outside that's your vertical asymptote. And in this case, that's exactly what it is. So I'm going to go ahead and I'm going to put 3 in the center of my table because I know that that's where my asymptote will be. So then I can kind of go 2 and 1, 4 and 5. This will be undefined. If I have 2 over 2 minus 3 plus 4, 2 over negative 1 plus 4, I get negative 2 plus 4. This is at positive 2. 2 is at positive 2. If I plug in 1 minus 3 plus 4, 2 over negative 2 plus 4 is negative 1 plus 4. So I should be at 1, I'm at 3. If I plug in 4, I have 2 over 4 minus 3 plus 4, which is 2 over 1 plus 4. 2 plus 4 gives me 6. And 2 over 5 minus 3 plus 4, 2 over 2 is 1, 1 plus 4 gives me 5. So at 1, I'm at 3. At 2, I'm at 2. I've already discovered that it can't quite touch 3. It seems to be shifting down. And we also talked about how our y then has to be 4. At 4, I'm at 6. At 5, I'm at 5, and then it's going to loop this way. But make sure, kind of like it just did for me here, that you don't have it, technical difficulties, that you don't actually have it touching that x equals 3 or that y equals 4. So loop, loop. Technically, this one on the bottom, I should fix as well, but for the sake of time, we're going to continue on. All right, so go ahead and pause this video and try to complete that checkpoint. All right, beautiful. So you should have discovered that your middle number, or the asymptote at this point, is negative 2. Then you have negative 1, 0, which you should technically go the other direction. And I noticed a couple of you guys are doing this. You want the smaller numbers on the top and the bigger numbers on the bottom. Something I've noticed quite a few of you do. All right, so I have 3 divided by negative 4 plus 2 minus 1. And please actually show your work here. There is no one that can do this in their heads. And if you're doing this in your head, you're going to make mistakes. So that's 3 over negative 2 minus 1. Negative 1.5 minus 1, negative 2.5. 3 over negative 3 plus 2 minus 1, 3 over negative 1 minus 1, negative 3 minus 1, negative 4. 3 over negative 1 plus 2 plus 1. We have 3 over 1 plus 1. 3 plus 1, we have 4. And 3 over 2 minus 1, 1.5 minus 1, we're at 0.5. All right, so at negative 4, I'm about at negative 2.5. Then at negative 3, I'm about at negative 4. We see here that our vertical asymptote will be at negative 1. Our horizontal, remember it's always the opposite of what's here to make that 0, would be at negative 2. So it's not going to, oops, let me erase this, vertical asymptote. So our horizontal, it's not going to touch x equals negative 2. And our vertical is not going to touch negative 1. So here it's not going to touch -1. And it's not going to touch -2. All right, -1, I'm at -4, and 0, I'm at 0.5. So here, it's actually above there. Okay, so at -1, I'm at +4. Don't you love these technical difficulties? Let me just get rid of this line, kiddos. There we go. Sorry about that. Now you guys see why I never use the iPad. All right, -1, I'm at 4, and 0, I'm at 0.5. So we're looping this way. And it does go down here. I know that because the line that it doesn't touch is at -1. And then it loops here. And that line it doesn't touch there is at -2. All right, perfect. Go ahead and complete the next task.